Good morning. Today we're going to start talking about section 7.3. What we're going to do here, I'm going to give my own little name on this section. I'll call it Factoring Trinomials, Part 1. All right, the next section, section 7.4, we're going to call it Factoring Trinomials, Part 2. Now what's going to happen here, we're going to be factoring trinomials, degree 2 trinomials of this form, something x squared plus something x plus a constant. And in this section, 7.3, we're going to assume that a equals 1. In other words, your lead coefficient is a 1. Okay? All right, and later on in 7.4, we will talk about factoring trinomials where the lead coefficient may or may not be 1. Okay? All right, so that's the deal for this 7.3 section. All right, let's start out with an example. This is example 1 on page 416, and we are asked to factor x squared plus 7x plus 12. The book says to do it by trial and error. What we're going to do actually here is try to unfoil it. In other words, attempt to break this down as a product of binomial factors. All right, there's a couple of hints here that can help us along the way. If the first term is x squared here on the left, well, that means on the right, the two first terms in the binomial expressions both have to be x. All right, there are some options here. We're going to, of course, look for factors of 12 in the last slots. We need factors of 12 that add up to 7 because 7x is going to be my outer and inner product sum. I think 4 and 3 will work. All right, a hint here. If this sign is positive, these signs must be the same. If this sign is also positive, then these signs must be the same positive. All right, so basically it's a trial and error method. I'll check my product here to make sure I get what I started with. X times x, the first product is x squared, plus the outer product, x times 3 is 3x, plus the inner product, x times 4 is 4x, and the last product, 4 times 3 is, of course, 12. And, of course, the inner and outer products here are like terms. So we can see when we multiply these binomials, our answer indeed does check. We get what we started with. So my final answer here, I would say x plus 4 times x plus 3. Okay, I've factored that as completely as I can, broken it down into a product of degree 1 binomials. Okay? I notice that multiplication is commutative, so I can change the order of these factors in my answer. Totally equivalent. Each of these answers is equally wonderful, okay, because, of course, multiplication is commutative. All right, now I want to look at example 3 on page 418. All right, here we are asked to factor a trinomial with a lead coefficient of 1. And again, we're going to do it in the trial and error process. All right, informally, my approach is to unfoil it via a trial and error process. Well, so I keep trying things until I find one that works, right? All right, if the first term is x squared, well, the first terms here will be x and x for my first product to be x squared. I'll need last products that multiply to a minus 6. All right, so notice if this last sign is negative, these signs in between here have to be different. One's plus and one's minus, right? All right, I think I see something happening here. If I say x6 is 3 times 2, all right, I can play around with the signs of the outer product and the inner product to add up to a positive x, right? If I have a plus 3x and a minus 2x, indeed 2 times x is 2x. I'm sorry, x times minus 2 is minus 2x. And the inner product, x times 3 is plus 3x. And I get plus 1x or x, which is what I need here. All right, let me try it again here. So the minus 2, the 2 will get a negative sign. Let me do that in yellow. All right, the 2 will get a negative sign. The 3 will get a positive sign. And I don't always insist that you check your answer. At least you should check it mentally. The first product is x squared. The outer product is going to be minus 2x. The inner product is, of course, plus 3x. And the last product is minus 6. Again, these two inner and outer products are like terms, and indeed they do add up to a plus x. So indeed this answer does check. So this is my answer here, x plus 3 times x minus 2. I have completely factored the given trinomial into a product of two binomials. All right, let's look at example 4 in our text on page 419. Again, we are to factor the given polynomial with a lead coefficient of 1, okay? X squared minus x minus 6. Again, it's a trial and error process. Since my lead coefficient is 1, I can fill in my first slots with x and x. All right, now my inner and outer product has to add up to a negative x, and the last product has to multiply to a negative 6. Right? All right, I think I see something happening here. If I put a 3 here and a 2 here, yes, I can play around with the inner and outer product. And the signs of those to add up to a negative x. Can I not? All right. Let's try it. If the 3 gets a negative and the 2 gets a positive, let's see. The inner product, minus 3x, and the outer product, plus 2x, indeed add up to a negative x, and that's what I need in that second slot. All right. So let me check this overall. The first product is x times x is x squared. The outer product is plus 2x. The inner product is minus 3x. And, I forgot an x there. And the last product, minus 3 times 2, is negative 6. So I get x squared minus x minus 6. And that indeed checks out. That's what I needed. And this is my final factored answer, x minus 3 times x plus 2. And again, you can write this as x plus 2 times x minus 3 because multiplication, of course, is commutative. Okay? Let's look at example 5. This is on page 419. Again, we are asked to factor a trinomial with a lead coefficient of 1, namely x squared minus 5x plus 6. All right, notice something here. This term is positive. That means when I factor, the signs in between here will have to be the same, either negative, negative, or positive, positive, right? All right, notice this sign here is negative. All right, so that means both of these terms, both of these signs in between in the binomial products, are going to have to be negative. That negative sign has to come from somewhere. It clearly couldn't be plus plus in these slots. All right, so noticing these shortcuts kind of helps us along the way to narrow things down. Well, 6, I think if I break 6 into 3 and 2, 3 times 2, I'll get what I need here. Let me check the answer. X times x is x squared. Minus 2x minus 3x is minus 5x. And the last product is, of course, positive 6, so that indeed does check. So my final answer is x minus 3 times x minus 2. We have successfully factored a trinomial into a product of two binomials. All right, let's look at example 6. This is also on page 419. They ask us to factor r squared plus 2r minus 24. Well, I see 24 and I get a little nervous because 24 has got a lot of possibilities. And again, this is a trial and error process. Well, because that lead coefficient is 1, I need r and r in the first slots. This sign here is negative, so these signs here have to be different, either plus minus or minus plus, right? All right, so let me think for a moment. R squared plus 2r minus 24. I think 6 times 4 is 24, and I think I can play around with the signs of 6 and 4 to get the correct inner and outer product. Notice the inner and outer product sum has to add up to a plus 2r. So if I tag a plus sign on the 6 and a minus sign on the 4, the outer product and inner product is going to be 6r minus 4r, and indeed will add up to a plus 2r. And notice the different signs here in these last terms. Plus 6 minus 4 does indeed multiply to minus 24. So I think we're done here. This is our final answer. Let me check. All right. The first product is r squared. The outer product is minus 4r. The inner product is plus 6r. And the last product is minus 24. Combining these inner and outer products now, I get r squared plus 2r minus 24, which indeed is what I started with. So this is my final answer right here on this line, r plus 6 times r minus 4. We have successfully factored a trinomial into a product of two binomials. All right, next we want to talk about example 7 in our text. This is on page 420. Factor x squared minus 8x plus 16. All right, another factor, another trinomial, a degree 2 trinomial with a lead coefficient of 1. All right, clearly I'm going to have to use x and x in the first slots here if I'm going to factor this as a product of two binomials. This sign here is positive, so these signs in between have to be the same, either plus plus or minus minus, right? Notice this sign is negative. This degree 1 term sign is negative. Well, that means these terms both have to be negative. Otherwise, that minus, there was no way for that minus negative 8 to be negative. All right, so let me clean this up a little bit here. That structure kind of helps us a little bit, eliminates some possibilities. Let's see, I need factors of 16 that add up to a negative 8, right? The inner and outer product has to be a negative 8. All right, so I think I see what's happening here. If I let those last terms be negative 4, I think we're okay. If we do a little check here, we do it in a different color. The first product, x times x, is x squared. The outer product is minus 4x. The inner product is negative 4x also. And the last product is minus 4 times minus 4 is plus 16. Of course, the inner and outer product are like terms and adds up to x squared minus 8x plus 16, which indeed checks. All right, so our final answer, x minus 4 times x minus 4. Notice that these two factors are indeed identical, so I could write this as the square of x minus 4. Could I not? Now, either of these answers, I would say, is wonderful, and both certainly equivalent. Next. Oh, by the way, I'm going to ask for the magic word in the quiz, in the online exam, and the magic word for today is surprise. All right? The magic word for today is surprise. So beware. Be sure to remember that on the online exam. Okay? All right, example 8. Example 8 on page 420. We want to factor x squared minus 11x minus 60. Now here I get very nervous because 60 has got a lot of different possibilities. I'll just list a few of them here. Well, let's see. If we take a look at this and consider the structure that the answer must contain, certainly I'm going to get two binomial factors with x and x in the first slots. Negative 60, well, that means these signs have to either be plus or minus or plus. And 60's got a lot of possibilities. 60 times 1, 30 times 2, 15 times 4. Right? What else? 5 times 12. What else? 16. Let's see, 20 times 3 is a possibility. 12 times 5 I already listed. 10 times 6 is a possibility. And, plus we've got to consider different options for the signs in between, either plus minus or minus plus. So it could be a real mess here if I check each and every one. What I'm going to do is try to see if I can spot it using our experience with multiplications of whole numbers. Let's see if I can arrive at a correct guess a little more quickly. Let's see, I need factors of negative 60 that add up to a negative 11. Well, let's see. What's going to work here? 15 and 4. 15 and 4. Yeah, 15 and 4 can add up to 11, right? If I play the signs right. Let's see. Let me put a 15 and 4 here. This residue the outer and inner product residue has to equal minus 11x. If I put a negative sign on the 15 and a positive sign on 4, indeed the outer and inner product are going to be minus 15x plus 4x, which is indeed negative 11x. So I think this will do it. All right? This will be my final answer. And again, if I want to check it, I'll do it in a different color. All right. The first product, x times x, x squared. The outer product, plus 4x. The inner product, minus 15x. And the last product is minus 60. So I've got x squared minus 11x minus 60 as my product, and indeed that does check with what I had originally. All right, final answer. Again, you can change the order of multiplication of these two binomial factors, and that answer is wonderful as well. All right, the next one I want to look at is example 12. On the very bottom of page 421, we are asked to factor this expression, 2x squared plus 2x minus 12. Now, a lot of students dive right in and try to factor this right away, but again, always look for a GCF first. In the examples up to now, there was no meaningful greatest common factor that could be factored out. But here you've got a 2 that's common as a factor to each term of this sum. All right, so the GCF here is 2. I can factor out a 2, can I? I'll have 2 times x squared plus 1x, or just x, minus 6. All right, so once I factor out that GCF, it makes my life quite a bit easier in factoring the remaining trinomial. Remember, you're going to be factoring twice here, so be sure to carry the GCF through to your final answer. I'll have x and x in the first slots. This sign is negative, meaning the signs in between here have to be different, either plus minus or minus plus. I need a plus 1x, or just plus x for the inner and outer sum. If I have a plus 3 here and minus 2 here, the outer and inner product indeed add up to a plus 1x. And final answer, 2 times x minus 3 times x, or x plus 3 times x minus 2. All right, one more, we'll call it a day. This is example 13, the last example in this section in the text. We are asked to factor the expression 3n cubed plus 24n squared minus 60n. Well, you may say, what's going on here? We were supposed to factor degree 2 trinomials with where the lead coefficient was 1. Well, the idea here is if I factor out a GCF first, it will follow that form, right? What's the GCF? Well, clearly I can factor out a 3 from each slot, and notice I can factor out 1 power of n, or 1 factor of n. All right, so that leaves me with 3n times n squared plus 8n, and clean that up, n squared plus 8n minus 20, right? All right, so I factored it once by factoring the GCF out, but I believe I can factor this again. 3n times, okay. Let's see if I can break down this trinomial further. I'll get n's in the first slots. I need factors of negative 20 that add up to a positive 8. I think 10 and 2 will do it. If I have a plus 10n for my inner product and a minus 2n for my outer product, those indeed will add up to a plus 8n. All right, largely factoring turns into a hunt and peck game for making sure the inner and outer products add up to this degree 1 term. All right, so I'd say this is done. Final answer, and again, don't forget to carry the GCF down to the final answer, 3n times n plus 10 times n minus 2. All right, this concludes section 7.3, Factoring Trinomials, Part 1. And again, remember, the magic word is surprise.